Next strategy in solving some trig equations involves doing some substitution and simplifying. So by substitution, we're talking about using some fundamental identities, things like that. Converting everything to the same trig functions, maybe making them all sines, maybe all cosines, all tangents, or maybe if I have a mixture of things, I need to make them all sines and cosines. But you have to be careful here. If you make some sort of substitute from one trig function to another, sometimes you get something that doesn't actually work out, so you have to throw that away. So just keep that in mind. On exercise 4, we have a cosine squared and we have a sine. If we tried to get that all on one side, we wouldn't be able to factor it. So we'd have to have everything in the same ratio. Fortunately, we have a cosine squared here, and we can easily turn a cosine squared into a sine squared using the Pythagorean theory, Pythagorean identity: sine squared x plus cosine squared x equals 1. So to get cosine squared x, I just subtract the sine squared over here. This is 1 minus sine squared x. So that's what I'm going to substitute in for this. So 2, open your parentheses, 1 minus sine squared x equals 2 plus sine x. Distribute your 2 over here. I can subtract 2's from both sides, they disappear. And to make our squared term positive, just add it over here to that side. So 0 equals 2 sine squared x plus sine x. Now notice that they both have a factor of sine x, so we can factor it out. What's left behind is 2 sine x plus 1. And as we've done before, set each of those factors equal to 0, so we'd have sine x equals 0 for the first one, and for the second one, 2 sine x plus 1 equals 0. On this left side, where is sine equal to 0? That's the y-coordinate. It's equal there at 0, over here at pi, and then 2 pi, and 3 pi, and whatever pi, which is n times pi, or pi times n, however you want to say it. On the second one, subtract the 1 over, divide by 2, so it's negative a half. On the unit circle, where is sine equal to negative a half? It's the y-coordinate over here in quadrant 3, which is 7 pi over 6, plus the period, 2 in pi. Or we can have one in quadrant 4 at 11 pi over 6. So x is also equal to 11 pi over 6 plus the period. Alright, on exercise 5, I've got a tangent thrown in here, sines and cosines, mixture of everything, so that's usually an indication you want to convert everything to sines and cosines. So I have cosine x plus sine x. Tangent is the same thing as sine over cosine equals 2. So cosine x plus, when I multiply this, I'll have the sine squared x over cosine x. 2. If I wanted to get a common denominator, because basically I have 2 fractions, then I need to put this over cosine x, and I would multiply the top by another factor of cosine x, which makes it squared. So when I add the fractions, I have cosine squared x plus sine squared x over cosine x equals 2. Top is just equal to 1. 1 over cosine x equals 2. And it looks like I'm about to run out of a little bit of time, so I'm going to stop here, pick it up here in just a second.